Okay, I had some technological difficulties, but we're back. This is the second part of 7-6. Remember that we are solving radical, tubular, super cool equations. Okay, so we already talked about a couple general examples, but here is the one that I was working on before. 2x plus 1 to the third plus 5 equals 0. Remember that our first goal is to always isolate the radical, isolate the radical, isolate the radical. You can think about this as a conservative government always tries to isolate the radical. Okay, so we're going to isolate the radical, which is to get this guy by itself. Minus 5, 2x plus 1 to the third equals negative 5. Okay, now how do we get rid of this third? Remember, by our rule that we talked about beforehand, which was if a equals b, then a to the n equals b to the n. Okay, so I can take this whole thing to the third power. Why did I choose 3? I chose 3 because this is the third root, and I want this to equal 1, right? So 3 divided by 3 equals 1. Perfect. So if I do it to that side, I have to do it to this side. So 2x plus 1 equals 5 cubed is 125. Now a negative times a negative times a negative is going to be a negative. So it's negative 125. And then I just do a little algebra. And x equals negative 63. And of course I can always check my answer by going back up here. And I'm just going to kind of walk through this vocally. Negative 63 times 2 is negative 126, plus 1 is negative 125. The cube root of negative 125 is negative 5, plus 5 equals 0. So this checks out. Okay, so let's move on. And I want to do another example, which is, yeah, I'll just make one up here. The square root of x plus 3. No, let's do this one. I like this one. Here we go. X equals the square root of x plus 7 plus 5. Okay, now remember, first step, isolate the radical. So I'm going to move this over. X minus 5 equals square root of x plus 7. Now I want to get rid of this radical, which means I need to square it, right? Because it's a regular square root sign. So I square it. If I square that side, I have to square this side. And this, remember, this is just turning a binomial into a trinomial by squaring it. So you can either use the just the normal squaring process, or you can use FOIL, or you can use the box method. It's completely up to you, but this is going to end up being a perfect square trinomial. So I'm going to use the process that I taught you guys. Remember, square the first one, this times this times this, which is negative 10x, square the last one. And that equals x plus 7. Now you might get kind of confused because you want to square this or do something crazy, but remember, these two basically just cancel each other out, leaving whatever is in here exactly right there. So x plus 7, x plus 7. Now, I'm going to move everything over to one side. Minus x, minus 7, minus 7. So now I have x squared minus 11x plus 18 equals 0. And we know how to solve this. I'm just going to factor it and solve each one for 0. So open it up, x is up front. What multiplies together to give, the signs of course are going to be both negative. What multiplies together to give 18? 9 and 2, which also add together to give 11. Yippee. So that equals 0. So my answers are 9 and 2, because 9 minus 9 equals 0. 2 minus 2 equals 0. And that's what I'm trying to find. Now, this is incredibly important. Remember what I told you about degrees? I said that the degree of the equation, the degree of the original equation, was going to tell you how many solutions there are. So if you look at this, what is the degree, the highest degree of these? It's 1. And so that means there's only one solution. but I have 2 solutions. So that means that I need to plug them in and double check to see which one works, okay? So let's look at the first one. 9 equals the square root of 9 plus 7 plus 5. 9 equals the square root of 16 plus 5. 9 equals 4 plus 5. True. So 9 is an answer. Let's double check the 2 and see what happens. 2 equals the square root of 2 plus 7 plus 5. 2 equals the square root of 9 plus 5. 2 equals 3 plus 5. 2 equals 8. Not true. Now if you look at this, you'll notice that the assumption was that we could have taken a what? A negative root, right? But we're only taking positive roots. Because if the square root of 9 was a negative 3 plus 5 does equal 2. But we're only taking positive, and that's why this is the only one that works. So you've got to check your answers. I always say that you should always check your answers on everything in life as well as mathematics. But make sure on these that you're checking your answers, okay? So I'm going to move to one more. And this is a doozy. If you can get this one, you are good to go. Don't be scared of it, but it's a little challenging. What you probably have noticed is that there is a radical on either side, okay? You can't do anything crazy. You can't add these together or multiply them into each other or things like that. You solve one radical and get rid of it, and then you get rid of the other one. Okay, but what that's going to make you do is it's going to make you FOIL or square this binomial that includes a radical. But it's not that big of a problem. You can definitely do it, so we'll just walk through the steps. So I've isolated one of the radicals. It's right here. Okay, so I'm going to square both sides. And that's going to take care of this radical. So that's just going to make this 2x minus 5. Done. Easy as pie. Okay? I don't actually think pi is that easy, both numerically or edibly. But now I'm going to square this side, right? So I'm going to use the perfect square formula, or you can FOIL it, or you can use the box method. But this is 1 squared, and then this times this times this. It's going to be 2x minus 3, right? Plus this squared. And what's this squared? Well, these counteract one another. And so it makes it x minus 3. And that makes sense, right? Because it's just, if I said the square root of apple squared, it'd be apple. If I said the square root of 9, which is 3, squared, it'd be 9. So the square root of x minus 3 squared is x minus 3. Okay? Why did I put it in parentheses? I put it in parentheses because it doesn't really matter here because it's a plus sign, but if this was a minus sign, that minus sign, as we've talked about, would have to distribute into both parts of this binomial. Okay? So I just put it like that always, and then I never get messed up. So now I'm going to rewrite it. 2x minus 5 equals 1 plus 2 square roots of x minus 3 plus x minus 3. Now, I want to isolate this radical. Okay? So that means I got to move this, 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 and then eventually this all over here. So let's just go through that process. 1 minus 3 is minus 2, right? So let's get rid of that. Plus 2, 2x minus 3 equals 2 times x minus 3 plus x. Okay? Is everyone okay with that? Now, minus x, x minus 3 equals 2 times the square root of x minus 3. Okay? Now, this is where it gets a little bit crazy. I need to get this by itself, so I need to get rid of this 2. How do I get rid of this 2? Well, it's connected by multiplication, so I'm going to divide it. Divide by 2, divide by 2. Okay? That's going to give me x over 2 minus 3 over 2 equals the square root of x minus 3. Okay? Now, what I need to do is square both sides. Okay? So, what that's going to do is this is going to give me x squared over 4 minus 6x over 4 plus 9 over 4 equals x minus 3. Okay? Now remember, I can get rid of all of these fractions by just multiplying everything by 4. So I'm going to multiply everything by 4, which is the common denominator. That's going to give me x squared minus 6x plus 9 equals 4x minus 12. Then plus 12 plus 12, x squared minus 6x plus 21 equals 4x minus 4x minus 4x, x squared minus 10x plus 21 equals 0. Now I can solve. X is up front, minus 7 minus 3, adds together give negative 10, multiplies together give positive 21. So my answers are x equals 7 and 3. Now, remember, I have to go through and double check this, as I always need to with these problems. So 2 times 7 minus 5 equals 1 plus 7 minus 3. Square root of 7 minus 3. So 14 minus 5, square root of 9 equals 1 plus the square root of 4. So 3 equals 1 plus 2. Well, that's right. So let's do the other one. Square root of 2 times 3 minus 5 equals 1 plus the square root of 3 minus 3. Okay? Now, 6 minus 5 is 1, so the square root of 1 equals 1 plus the square root of 0. 1 equals 1 plus 0. 1 equals 1. Perfect. So both of these are actually answers. And that makes sense because the whole idea of degree that we talked about earlier was complicated by the fact that the degree is actually 1/2 on these because there isn't an x that stands alone. So whenever you get, the rule of thumb is whenever you get an answer, no matter what your answer is, always plug it back in and check your answer. And in this case, both of them work. And that's it.